All right, so we proceed to the next slide. Here is this is the active circuit. So previously we have learned about the passive circuit where we have the RLC component, and mostly our examples is RC components. So now we have the active circuit. So basically the circuit have the op amp in it. So the op amp is used to amplify the signals that we have usually in a sensor circuit, also in a filter or controller circuit. All right, so basic for the op amp is we have this op amp here, and then we have negative and positive terminal, and then we have the input E1, E2, and we have the output E0 over here. Okay, so the equation that for this op amp is basically the output is basically is the difference of the two input here, E1 and E2 and E1, and multiply by the gain, K that is specified for this op amp. Okay, so we have E0 equals to K multiplied by the difference between two input, which at the terminal positive and terminal negative, E2 minus E1. We can also have in the reverse, where we have a negative K here, and then the difference between E1 minus E2, and because the E1 is actually the negative terminal and E2 is positive terminal, but both equation is will yield a similar result of A0 over here. All right. Let's see, the first one is inverting amplifier. So for the inverting amplifier, to analyze this active circuit, we need to understand that the op amp, the rule or the basics, the golden rule that for the op amp. The first one is that the current, the first one is current for the ideal op amp must not flow into the op amp. Okay, and then the second rule is positive terminal. The potential at positive terminal must be equal to the negative terminal. So the op amp will have similar potential at the negative terminal and at the positive terminal. Okay, so using this rule, we can obtain the equation here. So let's say the current I1, the current I1 here is given by the difference of potential between EI and E prime. EI and E prime. So we can say that I1 is equals to EI minus E prime over R1. Okay. All right. So next one is we want to find for current I2. So for I2, we have the difference potential between the R2, where we have a difference between E prime and E naught. So I2 is equals to E prime minus E naught over R2. Okay, so now we have these two equations, and we know that from the first rule here, the current must not flow into the op amp for the ideal op amp. But for the practical op amp, basically the current that flows into the op amp is very small. It's very small, so it is negligible. So we, in order for us to analyze the circuit, we can say that there is no current flow into the op amp. So meaning that the current flows only in this way, which we can say that I1 equals to I2. It is the same current. It is the same current. So we can put together this term. EI minus E prime over R1 equals to E prime minus E naught over R2. Okay. So using the second properties of the op-amp, the input sticks together. The input sticks together. Where we have the positive terminal here is 0. The input, we can say that at this point it is connected to the ground, meaning that the potential here is 0. So using the properties of op-amp, the input sticks together at the positive and negative terminals. So we can say that E prime also have 0 potential over here. So it is 0 equals to 0. At this point, it is said that this point is actually virtual ground. Virtual ground. Okay. Or virtual earth. Either one. Virtual ground. Okay. So we can say that using this equation, okay, using this equation, we put in E prime equals to 0. What we have is EI over R1 equals to negative E naught over R2. So our transfer function is output over input is E naught over EI. E1 EI equals to R2 over R1 negative. So for the inverting amplifier, we found that the transfer function or the gain of the inverting amplifier is equal to negative R2 over R1. Okay? Any question? That's why this configuration is called inverting amplifier, because we have output that is inverted from the input. If we have EI, the output will become negative E naught. Okay. Any question? No? So I proceed with non-inverting amplifier. Ni bila soalan ni? Doktor, untuk 1 over SC tu maksudnya apa? 1 over SC, tadi saya dah tunjuk dah. 1 over SC is actually, you can refer to the first slide of the modeling of electrical system. We have the capacitor. We have the capacitor. So the capacitor, when we have the current voltage relationship, we have this term. It's actually IT is equals to C dV over dt. C dV over dt. If we have the voltage current relationship, we have Vt equals to 1 over C integration of I t dt, I tau d tau. So basically, when we transform this term into Laplace, what we have is actually we have we put together something like this. We have the impedance. We have the impedance relationship, which Z equals to Vs over Is over here. what we have is actually we have in term of capacitor, we have 1 over CS, 1 over CS. Okay, so this is the special one lah, compared to resistor and inductor. Resistor is only R, inductor is LS. Okay, Shafiq, okay? All right. So next one is non-inverting amplifier. Okay, for the non-inverting amplifier, we can have the analysis similar to the inverting amplifier. We have two properties that we must take into consideration of the op-amp. The first one is there is no current flows into the op-amp. Then second one is the input, both terminal input sticks together. Okay. Before we proceed, we can convert the figure in A to figure in B. Okay, that is much more simpler to see as compared to figure A. So how to transform? Basically, we have the positive terminal. Okay, positive terminal here is connected to the supply voltage EI. Okay, so this is a positive terminal that connected to supply voltage EI. Okay, and then we have the negative terminal over here. So negative terminal we have one junction that is connected to R2 and R1. So we have at the negative terminal here one junction that is connected to R2 and connected to R1. And then R1 is connected to the ground. So R1 is connected to the ground. And R2 is connected to the output. So R2 is connected to the output. So this is how we transform the circuit to this better representation of this circuit for analysis. So when we see the circuit in B, we can see that is very much easy to analyze. Okay, so we can say here that the current from this op-amp actually flows in this direction, goes to the ground. So there is no current that flows into the negative terminal of op-amp. Because of the op-amp properties, there is no current that flows into the op-amp. Okay, so we can use voltage divider rule. Voltage divider rule to find the potential at this point. So let's say at this point we have E prime, E minus, E minus potential at E. So basically at this point is E minus over here. So E minus is we can find using the voltage divider rule, R1 over R1 plus R2 multiplied by E naught. Okay. And then we use the second properties of the op-amp, both inputs sticks together, which is E plus equals to E minus. So E plus here also will have similar equation as the E minus. So we can say that E plus is actually EI, because there is no voltage drop across the terminal. Okay, so we can say E plus is actually equals to EI. Okay, so EI is actually similar to this equation. So R1 over R2, sorry, R1 over R1 plus R2 multiplied by E naught. Okay, so finally, we can find the E naught over EI, which is R1 plus R2 over R1. So we can have 1 plus R2 over R1. Okay, so this is the transfer function for the non-inverting amplifier. Any question? Okay, if there is no question, let's go to the example 1 of this active circuit. So consider the following circuit that could be simplified as the next circuit. All right, so this one, we just simplify this portion as impedance 1, Z1, this portion as impedance 2, Z2. So we have transformed this first, the circuit on the left to the circuit on the right. Basically, we can see that this is actually the same configuration as the inverting amplifier. Okay, so you can use this the same analysis that we have discussed earlier for the inverting amplifier to solve this kind of question, and you can finally have the output or the transfer function of the circuit equals to negative Z2 over Z1, negative Z2 over Z1, and you can extract Z1 and Z2 into its component R2 and C. So you just can transform Z2. Basically, the Z2 is C and R2 in parallel. C and R2 in parallel, which you can find using this, and finally you will get Z2 equals to this. And finally, when you put it in together, you will have the transfer function of E naught over EI as shown in the slides. Okay? So make sure you go back and you do this practice, you this example 1 by yourself. Okay? We have now example 2. Okay, for the example 2, consider the following lead or lag controller circuit. Okay? Similarly, you can you can lump this portion into Z1 and another portion into Z2 here. And then this is we have another component here at this portion. So this is a lead lag network, lead or lag network, and then we have the another component here, which is the inverting amplifier. Sorry, this is sine inverter. Sine inverter. Inverting amplifier. So basically what we have is we need to find Z1 and Z2 first. Find Z1 and Z2. This is actually for Z1 is C1 and R1 in parallel. So we have R1 over R1 C1S plus 1. And for Z2 is actually C2 and R2 and in parallel. If you forget how to find it, please Google how to find parallel circuit. R2 over R2 C2S plus 1. Okay, so what we have is actually for the first portion of the circuit, we have EI is the input, E is the output. So we need to find E over EI. Okay, E over EI. So this is basically as the inverting amplifier. So basically we can say that it is a negative Z2 over Z1, which you just put it into put in the equation of Z1 and Z2, and you will find this equation. Okay, and next is we have another portion, E naught over E. We have this is the input to the next circuit. Okay, input to the next circuit is E. So the output is E naught. So we can find the output or the transfer function of the all the circuits is E naught over S over E S over here. So what is E naught over S is actually R4 over R3, R4, negative R4 and over R3 of S. Okay, basically this one. So you can put in E naught into the equation, so you will get something like this. Okay, again, go back and try this equation, try this example at home to familiarize yourself how to find the parallel uh, equation for the component, as well as how to find the transfer function for this active circuit. Any question? Okay, this is the end of this modeling of the electrical system, electrical circuit network. Okay, any question?